Welcome to the Nicholas 11X12 technology. Today we're looking at the Amd A4 3400 dual-core APU. APU stands for Accelerated Processing Unit. This means there's a CPU and a GPU on a single chip. But now let's take a closer look at a box of this product. When I first looked at this box, I noticed it was really bright red, and to me it's kinda dashy. At the bottom it says Amd A4, and in the center we see the core. When we turn the box around, on the top it says there's unrevealed DirectX 11 support. At the bottom we get to see the Amd A4 series logo. At the back of the box there are short descriptions in different languages. Another turn brings us to the dual graphics feature, which basically is Crossfire. This APU will only support the AMD Radeon HD 6450. Anything higher will not run in Crossfire. At the top of the box we see the model number, clock speed, the amount of cache and the socket this APU uses, which is FM1 by the way. And yeah, that's it for the box now. Very nice little one, I must admit. Once unboxed we get AMD's description and warranty. A small CPU cooler which tells us this APU will not run very hot. The fan is connected with a 4-pin connector. Thermal paste comes applied onto the heatsink. In the transparent plastic case we see the processor. My APU didn't come with a sticker for some reason. Now let's take a close look at this glorious accelerated processing unit. As you can see, it says AMD A4 3400 series on top of the APU. At the bottom of the APU where the pins are, we only see 905 pins here. Make sure you don't bend those, and please install the processor in the FM1 socket. I installed this processor in a Gigabyte GA A75M UD2H FM1 motherboard, which uses AMD's A75 chipset. I've also installed 8 GB of Kingston HyperX memory. For this review I didn't feel like using the stock cooler that came with this APU. Instead I'm going with the stock one from the AMD A83850 processor that I reviewed earlier. There's not much difference, just more aluminum. In CPU-Z under the codename it says Llano. This APU uses the FM1 socket and is manufactured with the 32nm architecture. Ultra low voltages, as you can see, the latest instructions are used, and the APU runs at 2.7 GHz at max and 800 MHz on idle. 1 MB of level 2 cache but no level 3. It's a dual core processor and uses 2 threads. In the mainboard tab you can see my motherboard I'm using, the GA A75M UD2H1 from Gigabyte. For the memory I got 8 GB installed and I'm running at 1600 MHz. Under graphics we get a little sneak peek but not too much. In GPU-Z we finally see the GPU we are using. The name is AMD Radeon HD 6410D and the code name for that is Sumo. Not too bad specifications here, good amount of transistors, 160 unified shaders, not bad at all. Of course there's full DirectX 11 support with shader model 5.0. 512 MB of DDR3 memory and 128-bit on the bus width. For the rest of the specs, not bad at all as well. Specifications. The name of this APU is AMD A4 3400. It's a dual-core Llano APU running at 2.7 GHz and has a TDP of 65 watts. 32nm architecture, 1 MB of level 2 cache, the AMD Radeon HD 6410D graphics and a dual-channel DDR3 1600 memory controller. Here's my test system I'm using today. Alright, now let's jump right into the benchmarks. In 3D Mark Vantage default performance preset, we get a decent score here CPU and GPU wise. As you can see, our 3D Mark score is P2269, and that's not bad at all, but not the best score obviously, but that's okay for an APU at this price point. The CPU score is not bad at all here, good enough for a dual core, 4692, almost 4700. On the GPU side, this APU shows its weak points with a little less than 2000 points. You quickly reach the limits and the score tells it all. But remember the price, keep that in mind. In 3D Mark 06 at default benchmarking settings, this APU performs a little better since it's DirectX 9 that's being used to render the graphics. But still, we get to the limits. Here are my results. 45, 89 3D marks here. For the shader model 2.0 test we get almost 1600 points. For the HDR shader model 3.0 test we get like 2000 points. And lastly our CPU score with around 2200 points. Not the best scores, but for older games this APU should do it very easily. Now let's take a look at the Cinebench 11.5 benchmark. Graphics are rendered using OpenGL. Here are my results. The CPU scored 1.56 points and the GPU 19.52 FPS. These results show us that this APU is not meant for hardcore video editing. Now we're getting to a very heavy benchmarking run. 3D Mark 11. The name is telling us there's full DirectX 11 rendering, and I can guarantee that this APU will fail here hard. But even some high-end systems are struggling on here. My 3D Mark 11 score is P593, almost 600. Very low scores indeed, but it makes sense. There's full stress on the CPU and GPU, and I'm testing an APU here that has both on its chip. And you know, this makes it harder to balance the performance percentage. In Lost Planet 2 we kinda see the same example with maxed out DirectX 11 settings. I maxed out everything as you can see, and I'm running this at 1680 by 1050. The average FPS in test A is 3.7 FPS and this APU ranked D. The average FPS in test B is 3.2 FPS and this APU ranked D here as well. It's time for the Unigine Heaven benchmark. Resolution is at 1680 by 1050 and everything is set on extreme settings including DirectX 11. The average FPS are 2.7, minimum 1.7, maximum 5, and the score is 67. Now let's test out the APU with Unigine Sanctuary benchmark. Resolution at 1680 by 1050 and everything else on highest settings. The average FPS are 9.4, minimum 6.6, maximum 11.9 and the score is 399. In firmware at 1680 by 1050 and no anti-aliasing, at benchmark no preset, I get some standard scores. As you can see I get around 220 points. The FPS range goes from 3 till 5 in this test. Now I'm testing the cache transfer speeds with AIDA64 cache and memory benchmark. This APU has some fast cache transfer speeds and so I can't really complain. Of course there's no level 3 cache, but that's another reason why the TTP is so low compared to processors with level 3 cache. In Maximum 2 preview we can measure the speed of the memory controller. Here are the results for the A4 3400, not bad. You can clearly see that AMD has improved a lot on the memory controller. Now this APU will run a SuperPi and run through 1 million calculations. As you can see it just completed and that in 27.425 seconds. Calculations are good enough for a dual core indeed. But enough for the synthetic tests now, let's run some game benchmarks on maxed out settings. As you can see I'm here in prototype and this APU isn't even so bad, especially on lowest settings. But for benchmarking I always run the games on max settings. In Battlefield Bad Company 2 on highest settings with this APU it is completely unplayable with 10 FPS on average. But now to Dirt 3. On the box we see this APU playing that game. We'll see if that's a lie or not. As you can see we got like 13 FPS on average on ultra high settings at my resolution. It's unplayable of course, but when I ran this game on lowest settings, even when I didn't lower the resolution, the game was still totally playable. So I'm talking of 35 till 45 FPS depending on the race location. So what we got to see here, this APU doesn't perform well on high settings but not bad on lower ones. In case you're interested on how the workload is balanced, here you go. I'm running the OpenGL test in Cinebench and for monitoring I use the AMD System Monitor tool. But sometimes you will experience laggy moments when playing demanding games or doing something else that's demanding to CPU and GPU. That's because it's an APU. It has to balance the power for both of these units. So each of these must be strong enough to keep up the FPS. And here's another thing I wanted to show you. AMD's APUs are sold under their AMD Vision Brilliant HD name. I can totally approve this. To enable and adjust the settings, right click your desktop and get into the AMD Vision Engine Control Center. Under the video, get to video settings. And you're there. Lots of options in here. Video color, brighter whites, dynamic ranges, video quality, video playback, so basically smooth playback, demo modes, and AMD steady video, which stabilizes your shaking camera work, for example. For the temperatures on idle, we get 15 degrees Celsius, which are 59 degrees Fahrenheit. That's very good, nothing to complain, but keep in mind that I'm not using the stock cooler that came with this APU. On full load, as you can see, I get around 50 till 51 degrees Celsius, which are about 124 degrees Fahrenheit. My ambient room temperature was at 19 degrees Celsius, which are 66 degrees Fahrenheit when I ran the temperature tests. We just came to the end of this review and it's time for the conclusion. Pros are excellent price-performance ratio, then this APU can play modern games on lower settings, and lastly the very low power consumption. And for the cons, I only have one thing to say: it just can play modern games on higher settings, but that's okay. For price, it's a very decent APU. So I give the AMD A4 3400 APU an 8 out of 10 and definitely recommend it. Thanks for watching.